Deep in the vast expanse of the cosmos, there shines a star that refuses to fade, defying the relentless grip of death itself. Its glow flickers with the stories of countless lives, each pulsating with hope, resilience, and rebirth. This celestial survivor dances on the edge of eternity, reminding us that some sparks refuse to burn out, no matter how dark the night. Stick around as we unravel the extraordinary saga of a star that refused to die, illuminating the incredible power of resilience amidst the silence of space. The mystique of the eternal star. At the heart of celestial phenomena lies a paradox that continues to intrigue astronomers and stargazers alike. Stars that defy the inevitable fade into darkness. These are not ordinary lights. These are the survivors, the luminous rebels that flicker with resilience across the vast emptiness of space. Their existence challenges our understanding of mortality in cosmic terms, whispering stories of rebirth and cosmic endurance. Such stars often become the focus of intense scrutiny when astronomers notice their unusual activity patterns or persistent brightness, hinting at internal processes that keep the light flickering long after conventional models suggest they should have faded away. The mystery of their longevity stirs a sense of wonder. What secrets do they hold that allow them to refuse the silent embrace of death? The phenomenon of an eternal star embodies contrasting realities: life and death, decay and renewal. Many luminous bodies in the universe have a finite lifespan. Massive stars burn brightly, then explode as supernovae, leaving behind neutron stars or black holes. Yet, certain stars seem to glow with an unnatural persistence, as though defying the natural order. Their indefinite endurance might stem from unique internal compositions or external influences, binary systems providing a steady fuel supply, or magnetic fields shielding them from the destructive forces that normally dim distant lights. The idea that some stars have found a way to sidestep the usual cosmic cycle ignites a poetic hope. Perhaps everything in the universe is capable of rebirth if only the right conditions persist. In a way, these stars serve as celestial symbols of resilience that resonate with human hopes for continuity amidst chaos. They shimmer as beacons of perseverance, often viewed through a lens of myth and poetic imagination. The most famous of these is perhaps the pulsar, a star that emits regular beams of radiation like a cosmic lighthouse, alive with pulsating energy long after the initial supernova. Pulsars challenge notions of finality. They are remnants, yet still vibrant, their rhythmic signals seeming to suggest a heartbeat that refuses to stop. Observing them feels almost like glimpsing a cosmic heartbeat, a reminder that some parts of the universe refuse to surrender to silence, to decay, to death. The rebirth of a star, whether through the collapse of its core, the accretion of matter from close companions, or other less understood mechanisms, embodies a narrative that transcends mere science. It touches the poetic core of existence, whispering of renewal in the face of demise. Their persistent glow becomes an emblem of hope and the tenacity of life itself, echoing the timeless truth that nothing truly ends in the grand symphony of the cosmos. Each flicker and pulse is a testament to the universe's unpredictable artistry, where even death can give way to a new dawn, sparking light again and again, an eternal reminder that sometimes refusing to die is the most powerful act of all. Origins of the celestial body. Long before a star dazzled with its luminous fire in the vast velvety expanse, it was born from cosmic chaos, an intricate dance of gases and gravitational whispers drifting through the universe. These stellar nurseries, molecular clouds, are sprawling regions where dust particles and hydrogen gas coalesce under gravity's gentle but relentless pull. Within these dense pockets, pressure and temperature slowly build, igniting nuclear fusion just enough to ignite the birth of a star. The very origins are a slow, deliberate symphony of matter seeking order amid chaos, a moment when the universe's raw beauty begins to shimmer with the promise of life. Yet, The story of a star's origins is never truly linear. It is intertwined with the death of previous stars. When massive stars exhaust their nuclear fuel, they explode in violent supernovae, scattering enriched elements and cosmic debris into the void. These remnants seed new stellar nurseries, giving rise to a repeated cycle. Death fertilizes life in an eternal cosmic rhythm. The materials expelled from these cataclysmic events serve as a foundation for future stars, enriching the fabric of space with heavy elements like iron, silicon, and carbon. It's almost poetic. Death breathes life into the next generation, a testament to the universe's unyielding resilience and renewal. The very core of a star's formation story is rooted in this interplay of destruction and creation. The dense, cold molecular clouds, often spanning light years, are aglow with turbulent motions, magnetic fields, and shock waves, forces that shape their evolution. Gradually, regions within these clouds collapse under their own gravity, forming dense cores that become the seedlings of stars. The process is slow, often taking millions of years, and yet in that span lies the potential to illuminate galaxies, to birth worlds, and to illuminate the boundless capacity of the cosmos for rebirth. Every star above us carries the echoes of countless cosmic deaths and rebirths, transforming rough chaos into radiant beauty. Imagine this origin story as a delicate balance, something remarkably fragile yet intensely powerful. Each star's birth is a testament to the universe's affinity for rebirth after demise. When a star begins to shine, it is heralding a new chapter, a phoenix rising from the ashes of cosmic futility. The very atoms that started as interstellar dust now forge the forging flame of fusion, a proof that even in death, there is a seed of life. It is this dance, this eternal cycle, that underscores why some stars seem to refuse to die entirely. They're born from the remnants of their own endings, forever entwined with the promise of renewal. Early observations and surprising stability. From the earliest points of scrutiny, the star that refuses to die has fascinated astronomers with its uncanny steadiness. Unlike many celestial bodies that either fade into obscurity or culminate in spectacular explosions, this star's apparent constancy defies conventional expectations. Initial telescopic observations revealed a star that remained remarkably stable, its brightness fluctuating only imperceptibly over decades. This surprising regularity drew immediate attention, prompting questions about the underlying mechanisms that sustain such persistence against the relentless march of cosmic change. The star's resilience rests on its core processes, which contrast sharply with the tumultuous nature we associate with stellar evolution. Instead of spiraling toward a dramatic end, it exhibits a stubborn endurance that many believed could not last. Early spectroscopic data painted a picture of a star in a delicate but enduring equilibrium, nuclear fusion balancing gravity in a quiet, resilient dance. Observers were struck by its spectral signatures, which showed little variation over time, hinting at a stable fusion process that keeps it from the chaos of rapid expansion or collapse. This surprising steadiness challenged prevailing models of stellar aging, casting doubt on the inevitability of death predestined for all stars. What makes this star's surprising stability even more poetic is its apparent defiance of life's typical cycle: birth, growth, death, and rebirth. Amid the cosmic symphony of explosive supernovae and swift fades into darkness, this star whispers a different story, one of perseverance and the possibility of eternal patience. Its surface temperature remains nearly constant, no signs of the tumult that might herald an end. This constancy hints at an internal mechanism that refuses to yield, a celestial testament to resilience that resonates deeply when contemplating life's fragile impermanence. In a universe of dynamism, the star stands as an enduring witness, silent, unwavering, and strangely alive. The initial observations, therefore, did more than catalog data. They invited pondering about stability itself in the cosmos. How can something so luminous, so massive, maintain such relentless equilibrium without faltering? This question lingers, fueling ongoing investigations. Its paradoxical stability fosters a sense of wonder, inviting us to see the universe not merely as a place of constant upheaval, but also as one capable of sustaining moments of astonishing calm. This enduring star becomes a mirror for our hopes of resilience and renewal, shining quietly amidst a universe that often seems fleeting and ephemeral. The celestial dance it embodies is a testament that some entities resist the pull of inevitable decline, offering a glimpse of eternal fire that refuses to dim. Theories behind its enduring brightness. Throughout the cosmos, some stars captivate astronomers with an almost defiant glow that persists beyond expectations. Bright beacons that seem to linger in the dark, flickering with vitality against the vast, indifferent void. Among these, the star that refuses to die has become a symbol of resilience etched into the universe's grand, shimmering tapestry. Beneath its brilliance lie theories shrouded in mystery and cosmic poetry, ideas that attempt to decode its sustained luminosity. One of the most compelling explanations revolves around the concept of stellar winds and magnetic fields that act as cosmic shields, preventing the star from dispersing its energy too rapidly. This magnetic embrace could channel plasma and radiation, allowing the star's core to burn steadily, defying the typical course of stellar death. Another line of thought voyages into the realm of exotic stellar objects, stars that are not quite what they appear to be. Certain types of neutron stars, for instance, known as magnetars, exhibit extraordinary magnetic fields that can influence their radiation patterns, sometimes causing them to shine with almost supernatural intensity for prolonged periods. These intense magnetic fields might generate continuous bursts of energy, giving the star a persistent glow. The idea of young white dwarfs, stellar remnants that are still cooling but radiating with residual heat, also adds a poetic layer as they burn with a slow, relentless fire. Their ability to slowly release stored thermal energy ensures their visible persistence long after their main fuel sources have flickered out, turning what many would see as a dying star into a quiet, enduring sentinel in the night sky. Some researchers propose that the star's resilience could stem from the possibility of episodic rejuvenation, violent yet periodic infusions of energy that reset its brightness. This concept is akin to the cosmos's own form of rebirth, a stellar phoenix rising not from ashes, but from the sporadic collapse and reignition of internal layers. Flare stars and certain variable stars demonstrate how internal magnetic activity and accretion processes can periodically boost luminosity. These stars, caught in the dance of death and rebirth, seem to defy closure, shining on with a stubborn, almost defiant glow. It's as if the universe delights in testing the boundaries between life and death. Each flicker and flare a testament to Shengmingde Buchu Wenao. In poetic harmony with the universe's infinite cycle, this star's enduring brilliance becomes a metaphor for resilience amid decay, a luminous whisper that life can persist in forms unforeseen. Its persistent glow signifies more than mere physics. It echoes a cosmic resilience mirrored in the universe's endless pursuit of rebirth. The star that refuses to die is a masterstroke of celestial endurance, an ode to the eternal dance of energy and entropy, standing as a luminous reminder that even in death's shadow, the spark of life can flicker stubbornly on, unraveling the star's unique composition. Beneath the shimmering cloak of the cosmos lies a beacon that defies the decay of age, a star that refuses to fade, pulsating with an almost defiant vitality. Its core, an intricate ballet of elements, reveals a composition that deviates from the usual lineages of stellar life. Unlike typical stars that burn through their fuel with a predictable rhythm, this celestial anomaly exhibits a layered, complex structure. At its heart, astronomers have identified an unusual abundance of heavy elements, metallicity in stellar terms, that imbues it with resilience. These elements, forged in the crucible of ancient supernovae, drift toward the core, providing additional fuel and stability amid the chaos of its internal processes. What makes this star particularly captivating is its unique balance of nuclear fusion pathways. Instead of relying solely on the standard hydrogen-to-helium fusion that powers most stars, it exhibits evidence of alternative fusion cycles, perhaps even residual processes from past evolutionary phases. These processes create a sort of internal mosaic, where layers of different compositions coexist, each contributing to the star's extraordinary capacity to sustain its glow against statistical expectations of its lifespan. It's this complex, multifaceted composition that grants the star a certain stubbornness, a refusal to succumb to typical stellar demise. Surrounding the core, a tapestry of radiative and convective zones interacts dynamically, hinting at a layered structure that sustains long-term energy output. Elements like carbon, oxygen, and heavier metals play crucial roles here, acting as catalysts in fusion reactions or as reservoirs that rekindle nuclear processes after their initial depletion. Their presence supports the star's ability to experience what we might call celestial rebirth, where the death of one phase simply leads to the birth of another in a perpetual cycle. In these layers, chemistry is poetry, each reaction of verse in the star's ongoing song of survival. This unusual composition isn't just a matter of academic curiosity. It unlocks potential insights into stellar evolution itself. It's a reminder that in the vast theater of the universe, life, such as it is among the stars, finds ways to resist its own endpoints. This star, refusing to sputter out completely, stands as a testament to the resilience woven into cosmic matter, an alchemical miracle of death and rebirth, delicately balanced on the edge of oblivion, yet resilient enough to endure. Its complexity whispers of secrets hidden in the atomic tapestry, revealing a dance of elements that defies the finality so often associated with stellar life cycles. The role of stellar winds and magnetic fields. Vast stellar giants breathe out streams of charged particles that form what scientists call stellar winds, a relentless gust of plasma streaming outward from their surfaces into the abyss. These winds are not mere breath. They're dynamic forces shaping the life and death of stars. For massive stars, winds can carry away a significant fraction of their mass over millions of years, gradually stripping them down to core remnants. Surprisingly, the intensity of these winds hinges on the star's magnetic field as much as its temperature and luminosity. Strong magnetic fields channel the charged particles along field lines, creating intricate and sometimes turbulent outflows that can influence the star's evolution in profound ways. Magnetic fields act like unseen sculptors, guiding the outflow of stellar winds into complex shapes that defy simple models. In some massive stars, magnetic confinement leads to the formation of magnetospheres, vast, magnetically trapped regions where plasma coalesces into dense, swirling clouds. These regions can produce peculiar spectral signatures, such as periodic variations in brightness or unique emission lines, betraying the underlying magnetic architecture. The powerful interplay between wind and magnetic field can also stabilize the star's atmosphere, temporarily resisting the instabilities that threaten to tear it apart, serving as both armor and an artist's brushstroke in the star's ongoing story of life and death. Supergiants like Eta Carinae exemplify how magnetic fields and stellar winds work together in cosmic rebirth. Even as these giants shed their outer layers, the magnetic fields confine some of the outflowing material, creating dense knots and filaments that will eventually seed new generations of stars. Remarkably, these magnetic-driven outflows can influence the star's future, delaying or accelerating its transition into a supernova. When a star's magnetic field is especially strong, it can channel the wind into jets that pierce through the cosmos, shimmering with the promise of rebirth amid destruction. Here, death's silence is broken by a symphony of magnetic and wind interactions, an eternal dance of decay and renewal. Thus, the star's refusal to die isn't random or solely dependent on its internal nuclear furnace. It's a delicate balance maintained, sometimes disrupted, by the forces of stellar winds and magnetic fields. These invisible yet persistent currents continue to mold the star's destiny, allowing it to linger in the universe's vast tapestry, whispering tales of resilience. In their silent, magnetic embrace, stars defy the finality of death, suggesting instead that even in decay, there is a potential for new beginnings. The universe's most enduring entities remind us that transformation often begins where chaos and order intertwine, on the edges of a star's breath and the strength of its magnetic heart. Anomalies in its life cycle. In the vast theater of the cosmos, some stars defy the natural script written by astrophysics. Among these celestial rebels, the star that refuses to die stands out, a luminous enigma whose life cycle transitions are riddled with anomalies. Usually, stars pass through predictable phases, spinning through birth in nebulae, shining as main sequence stars, swelling into giants or supergiants, and finally fading into remnants like white dwarfs, neutron stars, or black holes. Yet, this particular star persists, repeatedly challenging these telltale patterns, experiencing episodes that seem to distort the very fabric of stellar evolution. One of the most captivating anomalies lies in its repeated episodes of rebrightening, often called stellar outbursts, which seem to somewhat humiliate the traditional notion of a star's death. Instead of quietly retiring into a white dwarf or fading into obscurity, the star flares up unexpectedly, regaining brightness after periods of decline. These outbursts sometimes resemble chaotic fireworks, reminiscent of supernova imposters or luminous blue variables, but they never lead to the catastrophic explosion expected of aging giants. Instead, they hint at a complex internal engine, perhaps instability in its core or interactions with surrounding matter, that allows it to rejuvenate, at least temporarily. Furthermore, some observations reveal that this star's spectral signatures oscillate wildly during these events. Instead of smooth, predictable changes, the spectrum exhibits unpredictable shifts, lines indicative of fresh nuclear processes, ejected shells, or accretion episodes. These irregularities suggest that its core processes are far from settled, possibly involving unusual magnetic activity or mass exchange with a companion star. Researchers have noted that unlike typical stars that settle into a peaceful phase of decline, this star's life cycle is marked by a dissonance between its internal transformations and surface displays. It's as if the star is caught in a perpetual dance between death and rebirth, echoing an ancient myth of eternal renewal. The very existence of these anomalies forces astronomers to rethink the boundaries of stellar destiny. Instead of a one-way journey toward darkness, this star's life cycle resembles a cyclical myth, an eternal phoenix rising from its own ashes, only to flare up anew. Its repeated cycles of decline and resurgence blur the lines between life and death, leaving us to question whether the end is ever truly definitive. Each inclination toward obscurity is met with a stubborn flare of life, a celestial heartbeat that refuses to surrender. In the silent depths of space, where everything else eventually dims, this star insists on rewriting its story, an ongoing testament to the unpredictable poetry of the universe's most resilient beings. Impact on surrounding space and celestial mechanics. When a star demonstrates resilience beyond the expected boundaries of death, its influence ripples through the fabric of surrounding space with a force that defies simple explanation. The very act of a star refusing to fade entirely, whether through repeated nova explosions or unusual stellar rejuvenation, can alter the gravitational ballet of nearby celestial objects. These persistent luminosities and energetic outbursts inject turbulence into the surrounding environment, stirring up dust clouds, gas streams, and even smaller stellar bodies that orbit at a cautious distance. The delicate balance of celestial mechanics, in this case, becomes a dance of chaos and order, where the star's continued vitality shifts orbital paths and triggers gravitational waves that ripple outward at the speed of light. This celestial rebirth, so poetic and violent, can act as a catalyst for larger, systemic changes. For example, a star that reignites after a period of dormancy often sheds vast amounts of matter into space, enriching the interstellar medium with elements vital for the birth of new stars and planets. This expelled material, propelled by intense radiation and stellar winds, sculpts the nebulae that cradle future solar systems, thus influencing the chemical evolution of entire regions. The surrounding space becomes a living canvas, constantly reshaped by a star's refusal to yield entirely to death, imprinting new paths and structures into the cosmic core. In terms of celestial mechanics, the presence of such an energetic, reborn star can serve as a gravitational anchor or disruptor within stellar clusters or binary systems. Its fluctuating mass, whether through mass ejections or core reactions, causes subtle perturbations in the orbits of neighboring stars. These shifts may result in the migration of smaller bodies, comets, asteroids, or even rogue planets, out of stable zones, redirecting them into new trajectories or deep space pathways. Over eons, these alterations can influence the long-term stability of multiple systems, reshaping the architecture of galaxies itself. The star that refuses to die becomes an agent of cosmic renewal, quietly rewiring the celestial network with each act of survival. As the star's persistent radiation and energetic upheavals continue, the gravitational interactions foster an environment ripe with disturbance and harmony simultaneously. The dynamic interplay can lead to phenomena such as shock waves that compress nearby gas clouds, sparking star formation, or disperse them entirely, halting planetary development in some zones while nurturing it in others. The energetic rebirth infuses the surrounding space with vitality and unpredictability, reminding us that even in death's shadow, life finds a way to persist, redefine, and inspire. The influence of a star that refuses to die is not merely in its survival, but in the endless cascade of creation it sets into motion, an eternal reminder of the universe's capacity for renewal amidst chaos. Historical significance and cultural interpretations. Throughout history, celestial bodies have held a mirror to human hopes, fears, and ideals. The star that refuses to die embodies resilience beyond mere astronomy. It signifies a perpetual rebirth, an eternal symbol woven into the fabric of countless cultures. In ancient mythologies, stars were often perceived as sentient guides, serving as divine messengers that bridge the mortal realm with the divine. When a star shines unwavering against darkened skies, it sparks a narrative of perseverance, a shimmering reminder that even in the face of cosmic death, renewal persists. This celestial beacon's persistent glow has served as an inspiration for civilizations seeking meaning in the cycles of destruction and rebirth, echoing stories of resilience that transcend generations. In many cultural interpretations, such a star becomes a personification of the soul's undying nature. For some indigenous traditions, it is seen as a guardian spirit, a luminous symbol of hope chasing away shadows of despair. The star's refusal to fade away mirrors human contradiction, mortality intertwined with an innate desire for eternity. Artistic expressions across diverse societies depict this star as both a literal and metaphorical representation of transcendence, often illuminating myths surrounding heroes and gods who defy death, ascending or transforming. Its luminous perseverance sparks collective storytelling, becoming a narrative device illustrating that death cannot entirely extinguish the essence of life when the spark of spirit persists. The phenomenon also fosters profound philosophical reflections about the universe's cyclical nature. To cultures that observe stars as part of a cosmic dance, constant, shifting, yet enduring, the stubborn brightness of such stars symbolizes an ongoing conflict between impermanence and permanence. During eras of hardship or upheaval, the The star's unwavering light has served as a beacon for those seeking stability or meaning amid chaos. It whispers that mortality is just a chapter in a larger, ongoing story, one where the cosmic cycle of life and death continues with relentless persistence. These interpretations lend weight to the idea that the star's refusal to die is not merely about physical perseverance, but about the unyielding human spirit woven into the very fabric of existence. Thinking of this star as a metaphor, it evokes an emotional tapestry of hope and defiance. Its celestial rebirth, shimmering brighter after chaos, embodies a universal truth. In embracing the enduring glow of that celestial anchor, cultures come to see death not as the end, but as a portal to transformation. The star's refusal to die invites us to contemplate the potential for renewal within our own lives, raising timeless questions about what survives beyond the ephemeral, about the light that persists when all else seems lost. Its luminous resilience continuously fuels stories, rituals, and beliefs, tirelessly reminding us that some flames, whether in the night sky or within ourselves, are impossible to extinguish. Modern technological breakthroughs in observation. Sleek telescopes, powered by adaptive optics, now pierce the night sky with unyielding clarity, transforming faint whispers of light into vivid tapestries of cosmic stories. These technological marvels correct for atmospheric distortions in real time, allowing astronomers to observe distant stellar remnants with unprecedented sharpness. The advent of laser guide stars has extended this capability further. By projecting artificial beacons into the upper atmosphere, telescopes can measure and compensate for atmospheric turbulence instantly. This synergy of laser technology and adaptive optics has shattered previous limits, unveiling details of stellar remnants that once seemed forever shrouded in obscurity. Meanwhile, space-based observatories chart celestial phenomena free from Earth's atmospheric interference. Instruments like the Hubble Space Telescope have opened a window into the universe beyond earthly constraints, capturing high-resolution images of dying stars and pulsating nebulae in the ultraviolet, visible, and near-infrared spectra. These observations have fostered breakthroughs in understanding stellar death throes, revealing intricate filaments and shock waves that are invisible to ground-based eyes. The recent deployment of the James Webb Space Telescope promises to deepen this gaze, dissecting the faint glow of distant supernova remnants and even detecting the subtle spectral signatures of elements forged in stellar cores, a testimony to humanity's relentless drive to see through the veil of death in celestial bodies. Innovations in spectroscopy have equipped scientists with a toolkit for deciphering the chemical compositions and physical conditions within dying stars. By analyzing light spectra with high precision, researchers can detect elements like iron, nickel, and oxygen, tracers of the intense nuclear fusion and explosive processes that mark a star's final moments. These breakthroughs are made possible by basking in the synergy of multi-wavelength observatories, combining data from radio, infrared, optical, and 10th-ray observatories. As a result, remnants of stars are no longer silent echoes. They reveal their turbulent histories through spectral signatures that declare their rebirth, an ongoing dialogue between death and renewal inscribed in the language of photons. Emerging techniques such as very long baseline interferometry, VLBI, stitch together signals from radio antennas dispersed across continents, forming virtual telescopes the size of entire planets. This method grants an astonishing resolution, enabling astronomers to track the expansion of supernova remnants with exquisite precision. These insights inform models of remnant evolution, the dispersal of heavy elements, and the formation of neutron stars and black holes. With each technological leap, the universe unveils its secrets, whispering stories of celestial rebirth amid the ashes of stars that refuse to truly die. They pulse, shimmer, and live again through the eyes of humanity's most advanced observation tools. Recent discoveries challenging old assumptions. In the vast tapestry of the cosmos, Some stars seem to defy the finality of death with a stubborn resilience that baffles astronomers. Recent observations have shattered the long-held belief that once a star exhausts its nuclear fuel and sheds its outer layers, it inevitably fades into obscurity, becoming a white dwarf or black hole. Instead, scientists are now witnessing celestial remnants that stubbornly shine, sometimes even reigniting in spectacular displays of rebirth. These discoveries challenge assumptions rooted in classical stellar evolution, revealing a universe eager to surprise us with its capacity for persistence and renewal. One of the most captivating examples involves neutron stars occasionally bursting back to life through phenomena known as magnetar flares or starquakes. These intense magnetic eruptions can briefly elevate the star's brightness, revealing an inner vitality previously misunderstood as extinguished. The discovery of so-called zombie stars in certain binary systems showcases the incredible ability of some stellar remnants to resume accretion, reclaiming material from companion stars and igniting anew. This ongoing process blurs the line between death and rebirth, illustrating that a star's end does not mark the definitive end of its story, but perhaps merely a pause before another chapter. Furthermore, the observation of supernova remnants with unexpected activity has deepened the mystery. Instead of stagnation, some remnants appear to be reviving or sustaining small-scale fusion reactions longer than models predict. The case of Cassiopeia, a once thought to be a finished explosion, now exhibits signs of ongoing energy release, suggesting that the boundary between a star's death and a ghostly echo of its former self is far more fluid. These insights point toward a universe that allows for celestial phoenixes, stars that can rise from the ashes or linger in liminal states, challenging the finality once attributed to stellar demise. Ultimately, these discoveries evoke a poetic reflection on life's paradoxes, death as a transition rather than an absolute endpoint. They whisper of celestial resilience, of stars refusing to remain subdued by the silence of the universe for long. Instead, their flickering light shines as a testament to ongoing cycles of destruction and rebirth, an eternal dance that transforms the darkness into radiant hope. In a universe painted with stars that refuse to die, the very notion of mortality transforms into a dynamic interplay of fading and reigniting, reminding us that even in the cold void, there exists the possibility of luminous revival. The star's influence on nearby systems. The relentless glow of this star, defying the natural decay of celestial life, weaves an intricate web of influence across neighboring systems. Its radiance radiates far beyond its core, illuminating planets and asteroid belts in a dance of gravitational tug and energetic sway. This force is not merely luminous. It actively sculpts the environment around it, stirring stellar nurseries into life where otherwise darkness might linger. Gas clouds, compressed by the star's formidable gravity, birth new stars, igniting clusters that ripple outward in a chain of cosmic rebirth. Each of these newborn stars carries an echo of the influence that emanates from the indefatigable survivor, fueling the perpetual cycle of creation amidst the vast silence of space. The star's magnetic field extends its unseen fingers across the celestial neighborhood, raining in charged particles and shaping the space weather that affects planetary atmospheres. Planets orbit within its magnetosphere, experiencing auroras that flicker like celestial flames, manifestations of the star's unyielding energy. On some worlds, these magnetic interactions might even influence atmospheric chemistry, fostering environments where life, if it exists, must adapt to the pulsating heartbeat of their stellar parent. The star's persistent presence acts as a cosmic sculptor, slowly molding the character of its planets, determining whether they become barren wastelands or vibrant worlds teeming with potential. It's as if in refusing to succumb to death, the star insists on leaving a mark, an imprint of its indomitable spirit etched into the fabric of nearby systems. The insistent energy release from this dying star also impacts the smaller bodies that drift in its gravitational embrace. Comets and asteroids feel its pull, altering their trajectories in subtle but meaningful ways. Some are gently nudged onto collision courses, delivering cosmic gifts, ice, organic molecules, and other building blocks that could spark the origin of life. Others are flung far into the distant reaches of the star's influence, sent hurtling through interstellar space, messengers of a star's everlasting presence beyond its own lifespan. This continuous shuffle of celestial debris contributes to the dynamism of the surrounding environment, ensuring that even in the face of death, the star ceaselessly alters and invigorates its neighborhood in a complex, poetic ballet. Amid this grand dance of influence, a paradox quietly unfolds. While the star's death wavers on the horizon, its core collapsing in a final act of transformation, its gravitational and radiative effects persist with fierce tenacity. This duality of life and death imbues the cosmos with a sense of eternal renewal. The nearby systems, bathed in its lingering warmth and magnetic tendrils, carry the echoes of a star that refuses to vanish completely. Instead, its influence acts as a bridge, linking the waning brightness of a dying star with the birth of countless new worlds, forever imprinting its unyielding presence into the tapestry of space and time. Implications for stellar evolution theories. The case of the star that refuses to die pierces the fabric of conventional stellar evolution models like a shard of unbreakable glass. Typically, stars traverse predictable pathways. Massive giants shed their outer layers, cluster into planetary nebulae, or collapse into dense remnants like white dwarfs, neutron stars, or black holes. Yet, certain luminous giants defy this narrative, their persistent brightness and unexpected spectral signatures suggesting they have experienced only partial demise or have reignited after apparent exhaustion. These stellar survivors challenge the rigid boundaries of the Hertzsprung-Russell diagram and beckon astrophysicists to reconsider the life cycle boundaries we have long accepted. What makes these stars particularly captivating is their ability to sustain or reignite nuclear fusion processes despite previous phases that should have rendered them inert. For instance, some luminous blue variables or certain supergiants exhibit episodic outbursts that seem to blur the line between end-stage death and rebirth. Their atmospheres shimmer with complexities unseen in normal evolutionary sequences, shelf flashes, renewed mass ejections, or the emergence of unexpected chemical signatures, such as peculiar ratios of lithium or unusual heavy elements. These phenomena suggest that the stellar death process is not a single, definitive event, but a prolonged, turbulent saga, punctuated by unexpected acts of resilience. This has profound implications on models that assume a linear, definitive life cycle and indicates a possible need to incorporate phases of instability, renewal, or delayed collapse. The existence of these enigmatic stars compels us to revisit assumptions about the timescales and endpoints of stellar evolution. Traditionally, models depict a star's death as inevitable once it exhausts its nuclear fuel, after which it either sheds its outer layers or collapses into a black hole or neutron star, never to shine with such brightness again. Yet, these celestial anomalies demonstrate that under certain circumstances, perhaps influenced by binary interactions, magnetic fields, or specific initial compositions, the death process might be more like a series of pauses and revivals. Such scenarios could extend the lifetimes of star-like objects, producing a continuum rather than a clear bifurcation between life and death. Consequently, theories need to account for these survivalist stars as possibly intermediate or even prolonged phases of stellar existence, expanding our understanding of how mass, composition, and external influences modulate evolution pathways. In essence, these stars serve as poetic reminders that the universe rarely adheres to simple narratives. They embody resilience, defying finality, suggesting that death in the cosmos is not always absolute, but sometimes a misnomer, a temporary lull before the next act. As our telescopes sharpen and our theories evolve, we find ourselves navigating a star's twilight and dawn as a fragile, interconnected dance rather than a stark farewell. Their stories whisper that truth into the silent darkness. Cosmic cycles are more fluid, more complex, and perhaps more hopeful than the stark, linear trajectory we once believed. Their existence urges us to embrace the possibility that from the ashes of death, new light can still emerge. Partly because the universe, after all, is perpetually writing and rewriting its own tales of survival. The ever-persistent enigma, why it matters. Certain stars, despite the relentless march of cosmic time, refuse to fade quietly into the darkness. They burn with an unyielding intensity, defying the natural cycle of death and rebirth that governs most celestial bodies. These luminous beacons, often massive and vibrant, reignite the imagination and challenge our understanding of stellar evolution. Their persistence becomes a symbol of resilience amidst the vast, indifferent universe, a celestial paradox that sparks curiosity and awe. What makes them endure? Is it their specific composition, their unique environment, or some unseen force at play? Exploring these mysteries reveals not just the secrets of stars, but also a profound truth about resilience in face of inevitable decay. The importance of understanding these stars stretches beyond pure celestial fascination. They serve as cosmic laboratories, allowing scientists to refine theories about how stars live and die. When a star outlives expected death throes, during supernova or white dwarf formation, it challenges our models, nudging us toward new insights. For example, Eta Carinae, a luminous hypergiant, has defied expectations and continued to shine intensely through turbulent periods. Its life story prompts us to reconsider the boundaries of stellar longevity and the forces that can extend or rejuvenate a star's existence. These enigmas are not simply about distant points of light. They embody the enigma of survival itself, resonating deeply with human notions of endurance and hope. In poetic contrast to death's quiet embrace, these stars showcase celestial rebirths, glimmers of perpetuity in an otherwise transient universe. Sometimes, they seem to rise anew after catastrophic events, their light piercing through the void like a phoenix emerging from ash. The phenomenon of stellar rejuvenation, such as late-stage pulsations or unexpected brightening, mirrors the human struggle against mortality. It begs a question: why do some stars cling to life so stubbornly? Perhaps it is intrinsic to their makeup, or perhaps some cosmic anomaly, an unseen hand that whispers, "You shall persist." Whatever the reason, their existence beats like a stubborn drum against the silence of the void, reminding us that life, even celestial life, can find a way. Ultimately, these persistent stars tap into our collective consciousness, reflecting our own battles against despair and decay. Their luminous survival offers a metaphor for resilience that crosses cosmic boundaries, inspiring hope in the face of inevitable endings. Just as these celestial bodies seem to refuse their demise, mankind finds echoes of that refusal within to endure, adapt, and sometimes even reinvent itself. The universe's stubborn beacons encourage us to look beyond the horizon of mortality, to believe in the possibility of renewal amid dissolution. When we ponder why these stars refuse to die, we are also contemplating the indomitable spirit that exists in us all, an eternal spark that refuses to extinguish, no matter how dark the universe may become. Deep within the cosmic tapestry, some celestial giants refuse to surrender to the silent embrace of space's oblivion. The star that refuses to die embodies the relentless spirit of renewal amid the endless cycle of death and rebirth. Unlike typical stars that exhaust their nuclear fuel and fade into planetary nebulae or black dwarfs, these luminous survivors exhibit extraordinary resilience. They pulsate with an intensity that contradicts all expectations, as if defying the natural order with a stubborn gleam of life. Their existence becomes a testament to the universe's capacity to regenerate, to shock us with moments that shimmer against the inevitable darkness. In the vast realm of astrophysics, certain stars, after their initial death, ignite a second wind, a spectral resurrection that captures imaginations. These stars may initially fade from visibility, their outer layers dispersing into the void in a final act of cosmic theatricality. Yet, sometimes, remnants of their core endure, mere whispers of their former brilliance. Over time, gravitational forces or internal processes can coax these remnants into renewed energy releases, creating a spectacular show of rebirth. It's as if the universe secretly whispers, "Death is only a doorway," and these stars, with their stubborn persistence, chorus back with a defiant glow. Such stellar comebacks often involve violent upheavals, a nova or a supernova that leaves behind a neutron star or a pulsar. These dense, rapidly spinning objects emit beams of electromagnetic radiation that sweep through space like celestial lighthouses. Their pulses echo stories of ancient destruction intertwined with new beginnings, serving as cosmic proof that even in death, an extraordinary spark can endure. Their radiant signals cut through the darkness, a luminous reminder that life can fracture again, yet forge anew from the remnants, more resilient, more luminous than before. These stars become symbols of endurance, inspiring humanity's own tales of perseverance amidst the despair of inevitable decline. In wider poetic harmony, these celestial entities challenge our notions of finality. They prove that death is not an absolute curtain, but a phase in a perpetual dance of transformation. Their stubborn light, flickering defiantly against the void, whispers of hope, of rebirth emerging from the ashes of destruction. To witness their struggle is to glimpse a profound truth woven into the universe's fabric, that life's persistent heartbeat, even in the face of cosmic silence, is capable of rewriting its own story time and again, imbuing eternity with moments of fiery renewal. And so, the star that refused to die continues to burn brightly in the vast expanse, a testament to resilience against the silent march of time. It stands as a celestial monument, daring to defy death, igniting hope in the hearts that gaze upward. Life and death dance in an eternal balance. Yet this star reminds us that even in the darkest night, the spark of rebirth can still ignite anew. Resilient, radiant, unyielding. If this glimpse into the universe's infinite cycles has touched a chord, stay with us. The cosmos holds endless stories of rebirth and wonder waiting to be discovered. We'll be here, exploring the mysteries that dance just beyond our reach, eager to share more enchanting tales from the celestial depths. Keep watching, keep dreaming, because the universe's greatest secrets are just beginning to unfold.